All right. Welcome everyone to the EMS webinar. I'm George CK from the EMS Council, and I have the pleasure to introduce our next speaker, Professor Frank Lipnizki from Lund University. So Frank received his bachelor in manufacturing and management at the University of Bath in the United Kingdom, and his diploma in mechanical engineering at the University of Bochum in Germany. His PhD in chemical engineering, again at the University of Bath, focused on hydrophobic evaporation, in particular process integration and optimization. He was a postdoc at Lund University and then worked at Alfa Laval Business Center Membranes in Denmark. He also became an adjunct professor at Lund University, and later on, from 2017, he became a professor in chemical engineering, focusing on separation process in the Department of Chemical Engineering, again at Lund University. He leads the membrane group and manages MEM Lab, the university's industrial membrane process R&D. His main research interests include the integration and optimization of membrane-based separation processes in the food, biotech, pulp and paper industries, as well as in water and wastewater treatment. He also specializes in membrane fouling and cleaning strategies. So he was recently appointed as the president of the European Membrane Society. So Frank, congratulations on that. And I'm looking forward to work with you over the next couple of years. So maybe we can talk a little bit about the goals for the next 2 years for the EMS. Could you give us a brief overview about your plans, what you will be focusing on as the president?
Yes, first of all, thank you for this very kind introduction. I mean, one of the big challenges of the new council will be actually to keep up the work done by the previous council. That was excellent work, and yeah, I would also like to thank the previous council for their excellent work. And I mean, we have now a new, very enthusiastic council, and we hope to do some new things. I mean, the good thing is actually being president of the European Membrane Society is actually we are a growing society. So we're getting more and more members, and we are financially stable, so we can do good things for our members. And really, one of the key points we want to do is actually strengthening the collaboration between industry and also academia, because actually it would be very nice to integrate more industry in the European Membrane Society, because that will really benefit actually our young researchers in particular, because they could establish links to industry, and maybe some of them will then work at the industries later on after they finish, for example, their master's or PhD. And I think it's also important to mention that we are more collaborating with the other membrane society, with the North American Membrane Society, the Asian Membrane Society, directly or through WAMS. I mean, for example, in a couple of months in September, we will actually have a joint conference between the European Membrane Society and WAMS, Imagine Membrane, and so on. And it's really brilliant that two societies organizing together such events. And then last but not least, we hope to launch actually an event called Membrane Day, a day where we try to create actually awareness about membranes, membrane processes, and show actually people how important actually membranes are for our daily life. Because I would postulate actually in our daily life, we come at least in contact with one component or one product which is produced by membranes. And I'm not talking about water and wastewater, other products. And so membranes are an important part of our daily life. So I really hope that we have a great, successful, council now. And I'm really looking forward to work together with all of the council members.
Yeah, that's great. I mean, thank you for that. We've been already working together for 2 years. I think it's been great, and I'm looking forward to the next 2 years with your presidency. You mentioned industry versus university, and then looking at your CV, you spent a good number of years in both places. So what are the differences as a membrane researcher that you observed in industry and at the university? Or rather, what are the similarities? Maybe you can tell us about that with respect to your experience.
I mean, when it comes actually, in generally speaking, when you work in industry, whether you work in industry or in academia, I mean, one of the most important things actually that as a researcher working in these institutions is that you are aware of trends. For it's important to see what is actually requested nowadays, whether it's PFAS, whether it's microplastics, etc. And I think also both, whether you work in academia or in industry, it's quite important to have creativity to develop new things. But also, even in academia, it's important, I learned, to sell ideas. Because, I mean, in industry, I try to sell ideas to customers or products to customers. In academia, I'm trying to sell actually ideas to the funding agencies. So, I mean, we do in both areas, yeah, some sort of selling of ideas. But I think the main difference for me is actually that in academia, you have more freedom and you have a longer perspective. And
And
in
what are
industry,
the big challenges to actually commercialize membranes? Or how do you see that? Do we need more membrane materials, or we need to focus on more process development? What are your thoughts on that? There's a lot of debate around that.
I think personally, I think to develop new membranes, we need a closer collaboration between people who are developing membranes and people who are using membranes, because it's quite important that those understand each other, both each other. Because actually, when you look at the food industry, it's nice to develop a new membrane, for example, for dairy industry, which has an extremely high milk flux. Brilliant. But actually, for example, what about the long-term stability? Can the membrane be cleaned? What about actually the legislation, the FDA approval? Can it be used actually in the industry? So there are a lot of aspects which have to be considered. And that's actually one of the challenges, I think, to develop new membranes, because most of the membrane materials we are using nowadays are basically developed in the 1960s, 1970s. So there's actually, I mean, it's time for actually a major step forward. But I must also admit, when I look at the reverse osmosis membranes, I mean, to develop something new is challenging. I mean, the salt rejection of reverse osmosis membranes is close to 100. The fluxes are not too bad and are mainly determined by the module. So that's actually quite important aspect. So you have to look at the application, the membrane, and the module to actually move forward in this area. And we have to work there all together to achieve this.
Okay, and at EMS we have a lot of young members. So I think many of them are wondering whether they should choose academia or industry. What are your thoughts on that? And looking at your CV again, you move between the two. So sometimes students think that if they start with academia, they must stay in academia, or if they go to industry, they won't have a chance to return to academia. What are your thoughts on that?
I think the most important thing is that they are open to both work in academia and in industry. And I think the most important thing is actually to maintain connections and networking. Because actually, one of the thing which helped me a lot to go back and backward and forward between industry and academia was actually I had networks on both sides who were very happy to work together with me. So I think that is actually my strongest recommendation. If you have connections in industry or academia or vice versa, keep them, maintain them, and do networking. I mean, for example, really go to conferences like your membrane and establish contacts there. I think that's the most important thing, I think, for young researchers to do.
Okay, great, great. And maybe one final question before we actually move on with your research presentation. What was your most impactful industrial project? Is there anything in particular that you could highlight?
I mean, the one I was actually quite happy about was actually I developed a process for demudding of starch-based sweeteners. I mean, starch-based sweeteners, no one knows probably, but actually when you open your fridge and you look for high fructose corn syrup, glucose, fructose, I mean, basically these are the products which are produced with this process. And what I developed actually was a hybrid process consisting of a decanter and membranes to actually optimize this process and actually purify these sweeteners after they have been produced by saccharification and liquefaction. And the interesting thing was, and that's actually the interesting thing was actually, I developed the process with two colleagues. We had the idea sitting together, developing it. Then we did actually testing, small scale and large scale testing. And then we actually filed a patent. And last but not least, actually, we sold the process. And that was really quite amazing that you sell something and you see in the end of the day a process for a couple of million euros being realized on industrial scale. And after some startup hiccups, it was actually working. That was even the most interesting thing. I had some, interesting moments when the startup was not as smooth as I predicted, but in the end, everything was fine. And that was actually a great experience.
Okay, we might hear more about that. Looking at the title of your presentation, Developing a Membrane Application. Basically, the stage is yours, so I think you have about 20-25 minutes. And after that, we're going to continue with the Q&A.
Perfect. Thank you very much. Yeah, so I would like to talk about developing a membrane process, but I would like to also give you the opportunity, take the opportunity to briefly tell you where I am and a little bit about my group. I mean, basically, I'm located in Lund, which is actually very close to Copenhagen, the capital of Denmark. So we are actually on the Swedish side, and Denmark is on the Danish. Copenhagen is on the Danish side, and that's also related to the history of Lund University, which started 350 years ago. Basically, what happened 350 years ago is actually the Danish were kicked out of Sweden, and there was a Treaty of Roskilde. Basically, the south of Sweden became Swedish and is still since then Swedish. And to actually ensure that it remains Swedish, the King Carl the 11th decided actually to found a university in the south of Sweden, and that was Lund University. So actually, it took the king 2 years, basically nearly, to found the university, and that was great because actually when we were celebrating our 350th birthday, we were also celebrating a little bit more than a year. And I mean, when it comes to Lund, I mean, Lund is really a full university. We have 8 faculties, 3 campuses in the nearby cities. The main campus is certainly in Lund, and we have about 30,000 students. And when you think actually Lund, the center of Lund, they are living about 75,000 people. I mean, Lund is a true student city. So especially when you come here in summer, the city is empty, and the few tourists coming from abroad, they don't compensate for the students being at the beaches far away. So, I mean, this is quite nice. And we have also, I mean, Lund University is an important employer here in the region. I mean, we have 7,400 employees. The nice thing actually, when we're celebrating our birthday, I would say, we got also birthday presents. And one of the birthday presents you see in the left-hand corner, it's actually Max 4. It is the brightest X-ray source in the world, and it can actually supply 30 beam lines. So it's basically the largest synchrotron at the moment in the world, and it's basically standing about 2 kilometers away from me. Then we got another present, I would say, from the European Union, and that's ESS. And ESS is now starting up finally after years of construction. And when it's actually in operation, it will be the most powerful pulse neutron source in the world. So it's actually the largest microscope then in the world, which gives you actually images on atomic structures. One little comment to the little picture on the in the right-hand corner, basically to connect these 2 research facilities with the center of Lund, we got even a tram line. So we are probably one of the few small cities having a nice tram line running from the main train station to actually these research facilities through the university. When it comes to the membrane group, I mean, we are located in the so-called chemical center at Lund University. This is basically this big brown building you can see on the left-hand pictures. And as the membrane group, we have actually the privilege actually to have membrane facilities in 2 pilot halls. We have membrane facilities in the big chemical engineering pilot hall where you see the 2 arrows are going through, and there we have our membrane equipment, and also we have a good collaboration there with the process development unit for biorefinery processes. And we have also membrane units in the food engineering pilot hall. And that gives us unique opportunities, and we have basically something like 20 pilot units available for different types of membrane processes, from pressure-driven membrane processes to more advanced membrane processes like electrodialysis, forward osmosis, membrane distillation. And the nice thing is actually we are the leading membrane group here in Sweden. And the history of membranes at Lund University is actually over 50 years old. So it's actually a very established group. And we do both fundamental and applied research. But actually our focus is actually application development. And we have really the capability to move from lab scale to pilot scale. And most of my projects actually are related directly to industry, where we try to help industry to validate process ideas and to scale them up, and hopefully in the end of the day to have a full scale installation. I mean, to give quickly an overview about my research areas, it's the water, energy, food security nexus. And as you can see, there's in the middle, there's a membrane, and the membrane is dirty. That means actually in all areas, I mean, membranes by nature, they get dirty like children. And therefore, I mean, fouling and cleaning are important parameters to understand when you are working with membranes. Just to give you a very brief overview of some of the application we are working on. In the food industry, we are working a lot nowadays with vegetable proteins from underutilized byproducts. We look, so, for example, on proteins coming from the rapeseed production, hemp production, soya milk production. In dairy application, we are working with byproducts. For example, we sampled like whey and try to utilize them even better. But also then the sterile filtration of milk is an important area. When it comes to energy, we work a lot with biorefineries, specifically here in Scandinavia or in Sweden. We have a large pulp and paper industry, and we work together with this industry. But we look also on blue energy with membrane processes, like, for example, reverse electrodialysis. And one of the areas where we started now is actually battery recycling, because certainly, I mean, we will have more and more electric cars, hopefully. And in the end of the day, the batteries from the cars have to be recycled, and membranes can actually play an important role there. When it comes to water, I mean, water and wastewater treatment with membranes is important. And actually, Sweden, we have more and more actually installations of membrane bioreactors for wastewater treatment, but then also large installation actually for producing drinking water, for example, from surface water or from groundwater. And one of the areas where we are working a lot, and I will talk you about this one a little bit more, is actually stormwater harvesting with membranes. And this actually, the stormwater harvesting with membranes is actually related to the REVISE project, a Horizon 2020 project, which is actually coordinated by Aqualia in Spain. And it's a huge project. I mean, we are 30 partners in 11 countries, and we are running actually now to 2026, and we have a budget of 80 million euros. And here in Sweden, our focus is basically on 3 areas: rainwater harvesting and reuse, nutrition retention, and digital twin measure water balance. So we are having these technologies. And the very nice thing is actually we have 3 areas, new parts of the towns of Malmö in Sweden, where we try to actually integrate and implement these new technologies. And by showing actually politicians, businesses, and society that this works, we hope actually that we have an influence on policy making, business development, and social engagement. So what is actually the secret behind everything? Basically, when you look at the drinking water consumption per liter a day here in Sweden, I mean, what you can see very, very nicely is actually that a lot of drinking water is used for things where you might not need essentially drinking water. And thinking in particular about toilet flushing and washing. This could be actually 2 areas where you could actually utilize maybe good water quality, but not drinking water quality. And that was actually one of the ideas behind our project, was actually, can we utilize rainwater and upgrade it sufficiently that we can use it actually for some of the drinking water application without producing actually drinking water itself. And the concept we came up with was actually, we wanted to collect rain and storm water and then reuse it. I mean, one of the challenges was actually that rainwater and storm water can contain, for example, microplastics and micropollutants. And that's certainly something we don't want to utilize. So we really looked at opportunities. How can we do this better? And one of the solutions we came up with was actually membrane technology. And that's actually the initial concept we come up with. We have the stormwater tank. We have some submerged membrane modules in a tank. We have a little bit of aeration to have a cross flow over the membranes. And basically with a vacuum pump, which take out the purified water. And basically that was actually the first sketch we have drawn and we looked at, and we thought, oh, that works well. And basically we applied for the Revise project, and very luckily we got the money. We were also very, very lucky because actually we had a stormwater pond not so far away from the apartment. So basically about 800 meters away from here, there's a stormwater pond called Spexerdammen. You can see on the left-hand pictures. And we thought that would be brilliant if we could have a nice pilot there and run it. And we were very lucky because the company Lictec, a ceramic supplier from Denmark, they had a container which they were willing to borrow to us. And so basically we got a pilot container very fast to Lund and placed it next to this stormwater pond. I mean, we did not do too many lab scale experiments. We really jumped into the cold water and tried whether this works on pilot scale. And that shows also we were very confident that our idea could actually work. And we got the first results. And what you can see, actually, we were quite happy about them. The total organic compounds we would rejected by 44%, suspended solids by 94%, COD, phosphor nitrohydrogen. I mean, they were nicely rejected. So actually, it was very nice to see what we could achieve with membranes. And the membranes we used were microfiltration, ultrafiltration membranes of ceramic nature. Interesting was also when we analyzed the permeate, actually, we found out actually that we removed also a lot of heavy metals. And that was quite surprising because, I mean, normally you would not expect that microfiltration or ultrafiltration would do a great job on heavy metals. But it seems that most of the heavy metals present were actually associated to some larger compound. So we could actually nicely take them out and actually produce relatively pure water. We looked also actually on the bacteria, and actually we achieved nearly a 2-log bacteria reduction for different types of bacteria. And that was also we were quite happy about this. So, and there was actually room for improvement because one of the things we found out during the experiment was actually that one of our membrane sections was actually slightly damaged. So actually the result could have been better if we would have had, a perfect membrane section. But still, we were quite happy about this result. And I mean, this is actually the picture which speaks for itself. Basically, you see on the right-hand side the water which goes inside the unit. And when you took out the permeate, it was crystal clear water. So that was actually a very nice thing to show to people when they came to our test container. Take a sample from the lake, take a sample after the membrane and show it to them. And then, people believe what they see. So that was really quite a convincing argument that actually it works. Based on this very, very positive result, we actually had the opportunity to move further on. And there in the nearby city of Malmö, we have a new area called Sega Park, where actually they renovate some old houses to upgrade them actually to flat apartment buildings. So, and we actually had the opportunity to actually install our technology there. What you see at the bottom left-hand picture is actually basically the outlet from the stormwater tank. Basically, we installed some large stormwater tanks there that we can collect sufficient stormwater basically for one house. And we were allowed to install actually a membrane plant in one of their houses called Röda Oasen. And so we were very happy about this. And this basically how the installation looked like. I mean, it's a collective house. There are 44 people living. And we installed actually this membrane unit there. We collected the rainwater, and you can see, I mean, the rainwater when it came towards the unit, it was not so nice to look at, so it was slightly brownish. Then we had our membrane unit there, and we had a permeate tank, and the permeate tank, we had crystal clear water. The installed capacity officially is actually 1,000 liters per hour. But actually, when you look at the unit itself, it consists of 2 tanks. Actually, we can run up to 2,000 liters per hour if we want to. I mean, this was our first plant. And actually, when you do your first plant, you do it in a safe way. Also interesting is actually we started up in February 2024. And since then, basically, the plant is running without any major problems. I mean, the biggest problem we had actually was in the beginning, someone decided actually twice to stop the plant by switching off the electricity. We had to go there, switch it on again, and the plant was running again. So, but this was basically the most, the only major hiccups we had with the plant. So it was really well designed and very well installed. So, I mean, my colleague Tobias Hay did actually an excellent job. Just one more details about this installation. We have a membrane area of about 14 square meters of ceramic membranes. We produce actually 13,000 liters of water per day, and that's sufficient to flush 14 toilets and 4 washing machines. And the stormwater we are collecting is actually from the roof of the houses, but also from the surrounding area. And actually, one important thing, and that was actually a challenge, and it's still a challenge, is actually the installation has been approved by the local authorities, including a control plan for the water quality. So we're testing actually the water quality on a very regular basis, monitor it actually, and we hope to publish it soon. And it shows that actually the membrane plant is actually delivering a very consistent water quality. And we can replace about 40% of the drinking water consumption of this house, which is close to 500,000 liters per year, which we saved. Based on this enthusiastic approach, we actually got another opportunity closer to home. Basically, we got the opportunity to collect rainwater from our pilot hole. Basically, from this hole, we were allowed to take some of the rainwater, and we wanted to flush some toilet basically in our building, because we wanted to see actually how does it work in our environment. And also, I mean, it's nice to see it yourself. You can check the toilets and the membrane plant performance on a much regular basis when you have it so close by. So what we installed here was actually we installed a pipe which goes from 1 to 2, so from the roof into a collection tank, of which we have actually 2. So we have 2 collection tanks. Then we have actually a permeate tank, a membrane tank, where we have the submerged membranes installed. And then actually we have a permeate collection tank. And afterwards we have a pump, which brings then the water to 2 toilets and a washing machine. Interesting to note is actually that the whole concept, apart from the final pump, which brings actually water up to the toilets, everything is working on hydrostatic pressure. So basically it does not need any energy. And also the pump number 6 is only working when actually someone is using a washing machine or flushing the toilet. Otherwise, the pump is standing idle. So it's an interesting concept, and it's very energy efficient. And we started this now in March 2024. And so it's now running also for nearly it's nearly 1 year. And it's also running without any problems whatsoever. And that's actually quite nice indication that actually this technology is very robust. Some more pictures, what you can clearly see, you see actually the black pipe going into the reservoir tanks. Then you see actually the tank with the membrane unit submerged with ceramic membranes. And then you actually see the crystal clear water being used in a toilet. And basically the toilet has this nice logo attached to them. In this toilet, you flush with rainwater. And actually the toilet looks like a normal toilet. It is clean, and there's no problems with actually the rainwater, that we use rainwater. I mean, just to give you some indications, we looked actually a little bit on the tanks, and we did some analysis. Basically, we took samples of total solid samples of the unfiltered water, and you can see actually there is something in the jars. And then we took actually samples from the filtered water, and actually basically there was nothing to be detected. So actually the membranes are doing a very good job. based on this, actually, our university was very excited, and also the people who are actually in charge of the building, they thought actually, why can't we utilize this technology for the whole chemical center? So we were asked actually to make a proposal for a full-scale rainwater harvesting system for the center. And there was a certain demand. I mean, we have here in the center, we have 173 toilets, 3 washing machines, 1,000 workers, students per day, and we have 200 years of the years of working days. So that's basically our academic year. And basically, when we looked at the consumption, 2 flushes per person per day, 6 liters per flush, that gives us basically 12 cubic meters per day, or 240 cubic meters per month. We looked also at the washing machine, and we say 1 wash per day. A wash takes about 83 liters. That means we actually need, for our 3 washing machines, we need actually a quarter of a cubic meter per day, or 5 cubic meters per month. This together gives us actually, we need to produce actually something like 13 cubic meters per day, or 260 cubic meters per month. We looked also at what is actually the rain available, and the average precipitation here in Lund is actually 66 millimeters per month, and there's 1 millimeter rain equals actually basically to 1 liter per square meters. And we looked also on runoff coefficients with regard to asphalt and to the roof. And here you see actually basically the precipitation in Lund. And it was, for me, it was actually an eye-opener to look at this, because I was always surprised. I'm having my birthday at the end of April, and basically in April is actually one of the months where we have actually the lowest rainfall in Lund. So basically this unmystifies my observation that I have always sunshine on my birthday, but actually that helped us actually to design the tanks and also to design the membrane unit. What we looked at actually is how much area do we have to consider for collecting the rainwater, and how much storage tank we need to actually ensure that we have 355 days water for the toilets and washing machine in the center. So basically, when we took actually the roofs, some of the roofs and also the parking lots, we had actually a sufficient area to actually collect the rainwater, and we suggested actually to install two storage tank, a total of 120 cubic meters in size, on underneath the parking lot and underneath a green space. And that would be then sufficient actually to ensure that we can utilize the system basically day in, day out. And this basically how the system would look like. We would have 12 hours operation per day. The filtration rate would be basically a little bit more than 1 cubic meter per hour. And we would operate basically as a constant flux of 20 liters per square meters per hour. That means actually we need actually a membrane area of 55 square meters, and we would use actually 8 modules of about 7 square meters per module. So it's actually quite a compact, easy plant. And based on the success also that is we had so far, we actually also founded a company now, Celestine Water Tech, and that actually company is actually trying now to promote this technology further on, because that's also part of the Rewise project. We should actually take an idea, test it, develop it, and bring it then to the market. And that's basically what we are trying to do. And especially here in the area, we have a lot of interest basically from the towns who think it could be a great idea to utilize this technology for schools. Others in other areas, we are going to build here in Lund a new a house, new stables for horses. And actually there we see a big potential, because actually the local water companies already indicated that the water consumption for these stables is extremely high. So one should consider actually alternatives to get water for the horses, and that technology could be something. So I mean, we are quite happy, and so we are working hard to get this actually up and running and make it available for everyone. Some benefits and potential. I mean, basically, what I want to show to you, actually, reduction. We can reduce drinking water consumption by replacing actually drinking water with stormwater in application where you don't need drinking water essentially. And that actually is a reduction on the pressure on the stormwater networks due to local shortage, storage and consumption, which is also quite an important aspect nowadays because we have nowadays quite often very heavy rainfalls over a very short period of time. And there, these stormwater tanks, they have to be installed. And why not then, when you have to install these tanks, why not utilizing them for rainwater harvesting, actually utilizing them as storage tank for rainwater? And what we really want to do is actually we conversion of a wastewater, because normally rainwater would be normally treated as wastewater to a utility water. And therefore we hope really to contribute to this sustainability development goal number 6, clean water and sanitation. And I mean, we see really the potential that we can replace in average household the drinking water consumption by 30 to 40%. And basically, don't use drinking water then for gardening, car wash, toilet flushing, and clothes washing. Use rainwater. So, as a conclusion and outlook, I mean, approximately 45 liters per day and person are currently used for toilet flushing and washing machines, for which then basically drinking water quality is not essential. And really, the concept is to replace drinking water with stormwater upgrade to a quality which matches the needs of the purpose with membrane technology. So we really, I mean, I cannot emphasize it strongly enough. We don't want to produce drinking water. We certainly could take it the next step up to make drinking water out of it. But actually, do we need to do it because this extra step is an extra investment and it takes extra energy? So it has a requirement for OPEX and CAPEX. And do we really want to do it if we don't need it? And we scaled up to a membrane concept for stormwater harvesting, which are currently basically operating without any major problems. And they delivered the desired water quality. One thing we are working on at the moment is actually to improve the cleaning sequences. And we are certainly monitoring the long-term performance of the membranes, but also with regard to the water quality. And with this, I would especially like to thank you, Tobias Hay, who actually was mainly in charge of the installation, Oscar Brown, a master student, and last but not least, the Revise project. And I would like to thank you for your extension. And this is actually the membrane group here in Lund. And I hope to have some questions from you. Otherwise, you are also happy to contact me.
Thank you. Thank you for the nice presentation, Frank. So any questions from the audience? I'm looking at the chat. Please write your comments or questions in the chat.
Maybe while people are typing, I think one important thing everyone should notice, I mean, if you have actually comments or suggestions to the EMS Council, simply go to the EMS webpage. Actually, there you see the council members and their email addresses, so you actually can contact them and give your feedback and or your suggestions and comments.
Yes, I think the EMS website is going through a major revamp nowadays, so expect a continuous upgrade.
Yes.
Okay, so no questions yet, but I have a couple of questions, if you don't mind. So about the lifetime of these membranes, how much does that depend on the location and the type of the rain and the environment? Do you have any results on that, or it's limited so far to this building that you showed us?
I mean, basically, we have limited experience on this application with regard to the membrane life cycle. But what we know is actually our, I mean, in our pilot hole, the membrane unit, we have not cleaned a single time, and in the house in Roda-Oasen, we clean the membrane unit basically about every second month. And what we see so far is actually that it works very well with this limited cleaning. And cleaning is actually normally the factor which influences most the membrane life cycle. So we are confident to say that the membranes will last definitely 10 years plus.
That's great. And do you see any hindering effects with respect to geographical locations? Do you see this as a good water solution in other countries and regions as well?
I think so, because actually I think the interesting concept actually for a lot of region could be actually that the whole concept you can actually run at hydrostatic pressure, and you can actually basically produce microorganism free water, and also you will remove quite a lot of the suspended solids and total organic compounds. So I think that's actually something interesting for other regions, and you can do it even simplified. I would say even simplify more.
Okay, interesting. Usually we see a lot of presentations on advanced materials and fine materials, and here you focus more on the application side, which is definitely quite interesting. I'm looking at the chat again, if there are any questions.
People are very shy today.
Yes, maybe everyone is writing an email to you.
Yes, okay, good. I'm happy to answer them. That would be very nice.
Okay, let's give them one more minute, and then
Yeah.
if there are no questions, then I think we can close the webinar here.
Yes. No. Now, but basically our philosophy, maybe that I can say here at Lund University, is we think there are quite a lot of people working on developing of new membranes, and so what we really try to do is actually we try to utilize them to our best extent. And we do not only work with commercial membranes, but we are also working together with people developing membranes. So we test them actually in application, benchmark them against commercial membranes, and giving feedback then to the researcher how their new developed membranes are working. And some of them, I mean, they're working very well, so they have great potential.
Great. All right, so I think there are no more questions at this moment. So Frank, thank you again. Thank you very much for your presentation. And welcome as the new president of the EMS. And maybe one final thought, the announcement for the next webinar, we're going to have Lidiette Giorno as the next speaker in about 3 weeks' time. Okay, so stay tuned. Thank you, everyone. Thanks, Frank.
Thank you. Bye.